Hi, this is Team 4's presentation for COSC 3380 Homework 2, Phase 2. This is by Andrew Lee and Jacob Heggie. Our other two group mates decided not to contribute whatsoever. On the back of that, our work balance was split between our database and queries and then the front end and JavaScript setup for it. So Andrew handled all the front end configuration as well as setting up all the framework for how the actual JavaScript would connect to the front end. And I helped by designing and implementing the database, making sure it was normalized and making sure we covered all our bases, as well as helped debug all the queries and set up what we needed to for the JavaScript to connect with the database. So we sort of juggled those two and made sure that we helped each other with each other's responsibilities while also covering our own. So as far as the database goes, we started with the restaurant table. It is uniquely identified by its RID. Additionally, it has the street, city, and state attributes that identify its location. Then we have the customers table, which has a many-to-many relationship between restaurant and customers. The customers table is uniquely identified by its CID primary key. Additionally, it has the DOB or date of birth attribute, as well as loyalty card, CF name, and CL name, which is able to track each customer between each restaurant. We then have the products table, which is uniquely identified by its PID primary key. It also has the price attribute, the P type attribute, and the P name attribute, and has a subclass table combos with attributes item 1 and item 2 that is able to distinguish when a product is a combo and say what is part of that combo. We then have the employees table with a mandatory many-to-one relationship between itself and restaurant. It is identified by EID, its primary key, as well as EF name, salary, EL name, and E role comprising its attributes. It also has a subclass table, waiter, that has the tips attribute. As far as the foreign keys go, throughout this whole database, none of the foreign keys were used as a primary key except for bank account, which I will cover in a little bit. And that is by design because it is not necessary for us to do so. Because, for example, with customers, CID already uniquely identifies customers. We don't need RID to identify them. And beyond that, RID is not able to uniquely identify them. RID is not actually a prime column within the customers table. So CID acts as an independent primary key, and RID is not treated as part of the primary, as part of the composite key rather. So that is not something that we worry about. We now get into the transactions table. It is uniquely identified by its TID primary key. It has a many-to-one relationship with restaurant, many-to-one with customers, and many-to-one with waiters. It also has the method attribute, T-date, tips, tax, and total attributes that allow us to track various parts of a transaction. We have the complaints table with CMID that uniquely identifies it. It has a many-to-one relationship with restaurant, many-to-one with customers. It also has a CDate and CDescription attribute. And finally, we have the bank account table that has a one-to-one mandatory relationship with restaurant. It has a balance attribute, and its primary key is the RID of the restaurant that it correlates to. I just think we chose not to record any customer credit card data because as it stands as a restaurant, PCI DSS would already be something that we would have to abide by on the back end for processing credit card transactions. Regarding actually storing that data, it becomes much more complex where we have to have certain levels of cryptographic security and certain levels of security testing regularly, as well as consulting from a PCI DSS professional. So that adds a level of complexity that is unnecessary for what we're doing. So we chose not to store credit card data flat out, but that covers the database. And then this is an example of the JavaScript we have. So using the pool constant that we create, it just runs select transaction CID, transactions RID, customer CF name, customers CL name, employees EF name, employees EL name, transactions total, transactions tax, transactions tips, transactions method, transactions T date from, transactions join, customers on transaction CID equals customer CID, join employees on transaction CID, employees EID. So this is a double join. So we have three tables being combined, and this allows us to submit a transaction properly where we're able to track what the new transaction is and retrieve it, as well as get the employee's name instead of just the ID, as well as the customer's name instead of just their ID. So that is how we're using join in this instance.
Awesome. All right, I'll pick it up from here. We're going to jump into demoing this a little bit. So I've already got it running over here. When you first launch it, it starts you out on this dashboard. The point of this page is to show you specific details about a specific restaurant. So these are the available restaurants that we have already set up. So let's say I want to look at number 1. It's going to show me its location, the employees that are there, any transactions associated with that restaurant, and any complaints associated with that restaurant. You can swap it to, let's say, number 2. And again, it just shows you all the same information, but for that specific restaurant ID. And then along the side here, we have the different more custom views. So here you can see the menu. And all of these tables are going to be sortable by just clicking the header that you want to sort by. So like you can see all the different items that we have on our menu. This is universal across all 3 restaurants. You can jump over here to see the customers. Additionally, every page has a footer, and in that footer we're gonna list the SQL queries that we use on that page. And so you can see here we have a customer list, we have our employee list, and all of these tables are interactive in the same way as I showed already. Here we have the ability to add and remove employees, and then the SQL statement section. Sales ledger is going to be like your sales across all your restaurants. And here you can see the account balances for each restaurant. And then as well, you have a little bit of editing capacity here. Additionally, we've got a purge sales button, which will clear all the sales. And then every page, you can see the reset database button. That's going to reset it back to its init state. So any changes you make are going to be reset. Complaints as well, you can see all your complaints. And then we also have this front-facing page, which was like kind of implementing a lot of this. So if you were a customer, you could use this to say, I'm going to add some items from the menu here. So add number 3, I don't know, number 12. It doesn't, no rhyme or reason really. So you're here, it tells you your order here. I'd say I want to tip $2 because I'm cheap. We'll check out. All right, it's going to ask you what restaurant you want to order from. We'll order from number 2. And then we got to give it our name. Born this month, obviously. And I don't know. Yeah, I'm a loyalty member. I'm paying with cash. And we're going to submit. Okay, so it submits. So now we should see first sales ledger. It should show up as a transaction. Done. It also should show up is John Cena is a new customer. So it should have added to the customer index as well, which it has. Then let's say I want to reset the database. So I reset. It's going to make sure I actually want to reset. Boom. All right, now let's go back to our customer index. Oh, look, John Cena is gone. And go to our sales ledger, and that transaction is also gone as well. So that's kind of a demonstration of the different functionalities that we have for this project.